Okay, so yesterday we talked about the phases of matter and how the particles in those phases were arranged. So we've got the regularly tight pattern of particles in a solid, right? And then when we went to become a liquid, what we do is we increase the temperature, we're adding heat energy from the hot plate, right? Now I'm going to tell you something that's going to be interesting that you probably didn't know. When you actually change from a solid to a liquid, there is no temperature change. And you're like, what? Right, there is energy change, but there's no temperature change. And we can see this fact as recorded in a heating curve. Let's say we have ice that is below the melting point. So just like I showed you on that other assignment, if something is below the melting point, it is a solid. Right, so we've got some ice here below the melting point of water, which is 0 degrees Celsius. And if we add energy to it with, say, a hot plate or something like that, what's going to happen to that solid piece of ice? Well, it's going to get warmer. So we have on this x-axis, we have time. So as time moves on, as we're adding heat, it gets warmer. Once it gets to the melting point, we have a phase change. And the particles are beginning to come apart. So the particles are now coming apart, but they do not get any warmer. We are still adding energy though, so that means the particles are gaining energy. And the type of energy they are gaining is potential energy. Temperature is the measure of kinetic energy. So anytime temperature changes, there's a change in kinetic energy. So we're going to keep saying those words over and over again, potential energy and kinetic energy. Now, once all of that solid ice, all that solid water has changed into a liquid at 0 degrees, now if we continue to add energy, it's going to increase in temperature. And now what we have is a change in kinetic energy. Kinetic means motion and movement. So that means that the particles are moving quicker and quicker. If you recall yesterday, if the particles stop, we're at absolute zero. They don't have any temperature. All right, so we're warming until we get to the boiling point. So yesterday, we had this concept map, right? So if we're going from a solid to a liquid, it's an endothermic process. We're adding heat. If we go from a liquid to a gas, it's also an endothermic process. We're adding heat. So we're always adding heat energy. And we see the solid melts at the melting point. Solid becomes a liquid at the melting point. A liquid becomes a gas at the boiling point. And so in our heating curve, once we get to the boiling point, we're going to change that phase. All right, until we get to have that whole sample change into vapor or steam or gas, water, right? It's gas. We can continue to heat it up, and now we can heat it up as long as we want. We don't have another phase change. And so it can go up to whatever temperature as long as you keep adding heat energy to it. And the kinetic energy will continue to increase. So we've got anytime the temperature changes, it's a kinetic energy change. Anytime a phase changes, it's a potential energy change.